So welcome back, everyone. Welcome the competitors, and we also have here the jury members of Bosch and our wonderful team. So first of all, I hope that you can stay awake a little more hour.
Hello,
from
my
now
name
on.
is András, and
But
this is the video pitch.
but I don't know how many of you stayed for the night. Who was here all time during the weekend? Nice. Did you enjoy here? No. Okay. Okay, I'm happy if you do. So, as you may saw, we have 8 teams for the finalists, 4 from each challenge, 4 teams from each challenge. And the jury members choose these 8 teams. And now we will hear their pitches, their presentations. They will have 4 minutes to do a pitch. And then the audience can ask questions from them, or maybe the jury members. So I will call each team to the stage in an order that I previously shared with them. And first of all, we will play your YouTube video that you uploaded to Junction app. And then we are going to stream your presentation if you uploaded one. If you didn't do that, we maybe not will be able to present it, but hopefully you already did it. So I hope that everyone will get its YouTube video and the presentation as well. So I will start with the first team, and we will start with the hardware challenge projects. So we will have 4 teams from this challenge. And the first team who I would like to ask for the stage is the Green Dough Chapat team. Sorry. I'm a little bit tired as well. And we only have 1 microphone, but before you come to the stage, we will play your YouTube video. And as it's finished, you can come to the stage, but it's okay if you just come near to the stage, so you won't have to walk through the whole place. So I would like to ask the stream team to play the first video, which is for the green dough, right? Green dough. Okay. First YouTube video. Yes. Okay.
Hello, my name is András, and this is the video pitch for our project Green Dough, which is a smart, convenient and energy-saving window management option.
Our idea was to automate the ventilation of a room through a device that can open and close the window automatically based on user input, outside weather data, and also temperature and air quality measurements measured in the room itself.
We tried to calculate how much energy could be lost
In a flat by ventilating it too much and thus letting it cool down. This is of course a very rude model because there are a lot of variables that cannot be known by us, but it turned out that some money can indeed be saved this way, and if we can make the devices themselves cheap enough,
they could probably pay for themselves in about 1.5 to 2 years. The system consists of 2 main components, a sensor and a controller. The sensor is measuring temperature and air quality in the room itself, and the controller is the one that operates the linear actuator that actually opens and closes the window. Between them there is a 433 MHz RF channel, and the controller is communicating with the outside world through Wi-Fi. So with our project, the customer would be getting a basic smart home system that is very easy to install. It is scalable and can be used for a lot of other home automations and stuff like that, for example with the home assistant integration, for basically no money if he or she is using it long enough.
And now I would like to ask the team to come to the stage and also their presentation from the Steam team. And you have to use this pointer and please direct it to that way so you can switch between the slides. And
yes, thank you.
Okay, hi. Yeah, we didn't know that they will show the video to you, so it was basically a shorter version of the presentation, but I'm going to try to concentrate on the more important facts. So, yes, we are Greendow. We are a smart, convenient, and energy-saving window management option. Yes, okay, sorry. Yes, the main idea was to automate ventilation of a room through something that can control the opening and the closing of a window, and to do this with data points, more data points. These are the temperature and the air quality measured in the room itself. The outside weather got through Wi-Fi, and the desired temperature in the room got either directly by the user, set by the user, or through an already existing smart system or smart thermostat. I think I'm gonna just... So, yes, this is a 3D mock-up of our system. You can see the two devices. One of them is a wireless sensor operated by batteries. The other one needs to be wired because of the linear actuator that actually moves the window will use a lot of current. And I'm gonna now describe the system. If I can just... Yes, the system consists of 2D devices, and there is a 433 megahertz RF link between them. We needed this so that the sensor itself can use a lot less current because Wi-Fi uses a lot of energy, and this custom proprietary radio frequency stuff is much more energy efficient. In the controller that controls the window, there is an ESP that's basically communicating with the outside world through through Wi-Fi. This solution is pretty scalable because you can use either as many of these devices as you want, because this internal communication is very flexible, this internal network. It is very expandable because we have extra headers on both of the devices so that you can connect your own sensors if you would like. And it is very easy to use and integrate because of the ESP. That's a very common part, and it is very easily integrated into Home Assistant or something like that. You can see our block diagram here. I described basically all of it already, and you can see a more detailed, like, functional block diagram over here with the main parts included as well. So we also did a cost and saving analysis because that's very important in this challenge. Installation cost is basically free for us if you have already a power source near your window. Energy use is close to negligible, basically negligible. Our wireless sensor should be able to run on 4 AAA batteries for about 3 months if you're not using it too extensively. And the part cost should be around 85 euros. The PCB and assembly cost should be about 57 euros. We, of course, try to say something about how much energy you can save with this solution. This is very hard because there are a lot of variables that are unknown to us, of course, but we did a rough calculation, and from our estimations, in a small flat, a pair of these devices could probably pay for themselves in 2 years. Yes, so we created these boards as well in KiCad. This is just an example of the radio frequency part because I think that's the part that we are the most proud of, probably. We are using a silicon-less chip for this. We created the layout for both of the boards as well. You can see the controller on the left with the big ESP pads, and you can see the sensor on the right. We have some air ventilation holes because the air sensor that we are using needs a bit of airflow to be able to operate accurately. And we have also created 3D models of these parts. It's also in KiCad. You can see that on the sensor we have a small vent that is running at a very low RPM and at a very low power. We just needed to move a little bit of air through the air sensor. And yes, I think that this was the conclusion of our work. So sorry for the technical stuff, and thank you for your attention.
Thank you. Do we have questions to the team? Anyone from the audience, from other teams, from the jury? Okay, then thank you for the pitch. And let's see the next team. But before I would invite them to the stage, I would like to tell you a little bit about how to vote. So each team will be uploaded into the Junction app. You will see a final voting panel on the left side in the dashboard of the event. And there you will see the 8 teams, and you can take your vote to one team. You can change the vote. So one team member can vote for one team. Is it okay? Because I see such surprised faces, but okay. So you can vote for one team, and then we will summarize the votes of you, the competitors, and also from the jury, and then we will merge these votes and get the results. That's which team got the most points from the voting. And as soon as we start the grand winner voting, we will have another kind of voting process for the audience award prize, which is €500, and it will be available in the Facebook event through a Google form, because Facebook decided today that they delete the poll option in Facebook. So we had to come up with another idea. So don't be surprised, but we will use a Google form, not an actual poll in the Facebook event. It's just an additional information to you. But the votings will start as soon as the last pitch ends. So you will see the finalist panel right then. We will open it, and then you will have around 10 minutes to vote, because during the voting we will have a Bosch representative who will give over the challenge prizes in the meantime. So that's it about the voting, and let's see the next team who also submitted the project to the hardware challenge, and the team is just a minute. The Where To team. We will play your YouTube video, and then you can come to the stage. Where is the team? There. Perfect. Okay, then wait there, and after the video you can come up.
Good afternoon, everyone. Here's a solution for the hardware challenge from Code Like a Bosch. We are going to use an S32 based microcontroller. So we chose the room because it's easier to find resources for it. And besides that, we are also going to use this HTML transceiver for Zigbee, for the protocol Zigbee. So our idea is to have the S32 microcontroller to measure the position of the user, or at least estimate it, using the Bluetooth low energy device that user can have at any time. And with that, feed this data to a predictive model running in the server, so it can predict the next positions of the user and prepare the ambient for the user. We're going to use this temperature sensor, so it has 0.4 degrees Celsius precision, so it's a really good precision for this type of applications, and it's going to be mounted outside of the board, connected to it with a cable, so it doesn't get biased by the board temperature. For our power supply, we are going to use switch mode power supply. We are going to have 2 voltages in the board, 3.3 volts for the ESP and 1.8 volts for the HTML transceiver. For measuring the light, we are planning to use 3 LDRs, so they will be in an angle, so they can better get the light intensities in the room. And that's it.
Such a short video. That's okay. Then please come to the stage and present your idea in live as well. You will have 4 minutes. I will count time, and I also give you a pointer, which I would like you to use it in this way. And this is a useful information for the next teams as well, because if you do the pointer this, then it won't catch the sign, okay? So try to point there. Okay, and the microphone. Can we get the presentation as well? We have one. Just a few minutes.
I uploaded. Hi guys, so sorry for that video. I wasn't aware that's going to be live for you. I thought it was only for the jury. So it wasn't the best one, and also no sleep, so sorry about the quality. I'll try to make it up in this presentation. So we are the team War 2, and we try to develop a technology to technical problem. We try to develop a technology to track the user, the homeowner, while they are in their own house. So we can turn on the heater or lights turn on the heater and the lights only where the homeowner will be at or will go into. So with this, we can decrease the gas usage and also the electricity usage in empty rooms. So here's an example. We have, for example, one house in the winter. It's normally cold unless you leave your heater open 24/7, and we don't want that. So the idea is to have a base temperature that is comfortable but not warm enough to be really expensive, and set the temperature in the house to be around that. And when the homeowners start walking around the house, this solution will try to guess where it will be going to in some minutes, and so already turn on the heater so when it arrives in the room, it's warm enough to be comfortable. So this idea is based on a hardware that's the sensors that we developed, and also some software running a server. The software running the server will be a Markov chain. It's a basic predictive model that uses mainly only the current solution. And for the hardware, we are going to use the ESP for brains and Bluetooth low power. 3 LDRs, so it can get a wide angle of the light in the room. This new temperature sensor, it has some perks I'll talk following. And it will also be operated by battery, 3 AAA batteries, and we have a Zigbee transceiver. So why this ESP, why this microcontroller? We use it because it has Bluetooth Low Energy. It's easy to configure, and there are more features. So this is mainly used for the prototype version because this is an older version and it's not supposed to be used for new designs. But for a prototype, it was easier to find all schematics and examples with this hardware. For the temperature, we chose this Texas Instrument sensor. It can communicate with the microcontroller using SPI, so it's really easy to set up. It has a really good precision of 0.4 degrees Celsius, and it's really cheap, so it's a good idea for a solution that can be scalable well. So for the light measuring, we chose the LDR because it's the simplest there is and it's reliable. So we can use it as a voltage divider and get the general lighting of the room, and then we can decide what to do about lights in that room. For the communication between the different sensors and the server, we are going to use Zigbee because using Bluetooth or Wi-Fi wouldn't be reliable if the solution is really scaled, if you have a lot of sensors and boards in the homeowner house. So with Zigbee, it's easier to maintain this reliability. Also, as doesn't have from the factory already some Zigbee transmission, we had to use this Atmel transceiver so we can forward the messages using this protocol. The cost, we were required to estimate the cost of the boards when we used up to 1,000 units. If we build up to 1,000 units, we can get the boards for over than 20 euros. And that's considering our manufacturing using GLC PCB and all the sensors. There might be needing a bit more for the enclosure of the sensor and some other technologies to actuate on this sensor. And that's it for our presentation.
Great. Thank you. Don't go yet. Don't go yet. Is there any question from the audience? No. Okay. Thank you then. Okay. So we have a little modification in the order because I would like to ask the fourth team to come to the stage, and then the originally third one will be the fourth, okay? Yes, and I can see that we already have their video. So I would like to ask the Thermoflow team to the stage right after we played your YouTube video, okay? Yes. Please come to the stage and tell us what this was about, because I'm now really curious about it.
Good afternoon, everybody. Can I have the presenter? Oh, it's here. Good afternoon, everybody. My name is Matyi, and I am going to be presenting in the name of my team today. So, in today's geopolitical situation, energy prices are getting higher and higher every day. So we created a smart home solution for lowering those prices by making the heating system more efficient by ventilating the air. Okay, it's a bit too much. Okay, so, okay, sorry. So as you can see, we made a CFD simulation where you can see that through the window, I wasn't stepping. So there is a lot of heat coming in the windows down, and we can, by ventilation, we can get that airflow through the house and making it more warm. And for this, we are using a sensor grid. We are placing a lot of sensors throughout the house, and we have also active components for it because we can, with actuators, we can open the windows and the shutters, creating all these things necessary to make an airflow. It's really cost saving. The financial return is happening only in 3 years or 4 years. There are a lot of health benefits, and we can make your house really comfortable by having always that really fresh air and always the best temperature needed. For the hardware, we have, I mentioned, we are placing a lot of sensors. We have pressure and temperature sensors in every room, one close to the floor and one a little bit higher. Also, we have these sensors outside the windows, so we can count all the flow coming through the house. We have CO2 and CO sensors close to the floor. Also, we have VOC, it's a volatile organic compound sensor, and humidity sensors only in the kitchen and the bathroom to prevent molding, for example. I will talk about it later. We have actuators, as I mentioned, for the windows and the shutters, and we are using the floor heating system also for this ventilation. And we have to place these sensors in packs, in kits, and we created unique PCB designs for that, so that we are able to have the best pack for the systems. Yeah, I mentioned we have a lot of health benefits. We have a doctor in the team, a doctor student, so he told me a lot of things in an ancient language. So the most important thing, we can prevent molding in the houses and with the air ventilation system, and that can prevent cancer, for example. And we are using ambient lighting for a lot of things. We can help your circadian rhythm. It's basically your sleep and awake time, and we can increase this time and its productivity with lights, and we are using smart light bulbs for it. Also, mental health is really great and gets better, and productivity gets better, when you're learning and you get this fresh air, and everything starts to get really, really productive. And there are a lot of other health benefits. I can't really talk in detail about those. And yes, we have a financial plan also for different price plans, and we are going to we counted that our cost of product is around $1,000. Also, of course, it depends on the house, how big it is, how many sensors it needs, and we counted in different houses too how many saving you have, and you can the financial return happens in about 4 years. In a suburban house, you can save $300 a year, and we are using a heat perception illusions by the lighting, for example, that you will film the room is more warm than it didn't actually is. Really, thank you for your attention, and yeah, the mosquito. So we have a unique solution because we are using sensors that measures CO2, for example. Mosquitoes are going to CO2s and to temperature, and this way, when you are sleeping and you feel that the mosquito is coming to you and you just can't sleep, we can create like fake human perceptions for the mosquitoes, and it can carry it away. So thank you for your attention.
Okay, questions? No one? Are you really that tired? You don't have any questions? There is a question.
first part. Yeah, so if somebody wants to break in, a window won't stop in. So you can really easily break a glass window. We also have this, so because we are measuring all these temperature and airflow systems, we can also have an emergency system that alerts us when somebody comes in that window. So it also functions as a safety protocol too. It's a hardware challenge, so we don't do it. Anything else? Thank you.
Thank you, guys. You made a great job, I think. Next time you can submit your project to the excuse me? Okay. So next time you can submit your project to the software as well.
12 months.
And now we will see the last team from the hardware challenge, the Superset by Team Discover. Let's see their video and then they can come to the stage, or they already did, and play some demo, I think.
In the last 12 months, natural gas, the EU's most popular energy source for heating, has become 6 times more expensive. In order to save on energy, we need adaptive and automatic systems, but how could we make this work when most households still have heaters like this? This is why we have created Superset, a smart home solution that helps to optimize energy consumption in households with traditional heating systems. The network is made up of sensor cubes, which include temperature, humidity, and motion sensors. In just under 36 hours, we have put together a fully working proof of concept where the cubes gather and send data to a dashboard where visualizations and recommendations help the homeowner. The cubes are placed in every room to continuously measure and calculate the optimal heating plan, which is personalized to the habits and daily routines of the homeowner. Measurements from the cubes are collected on the Superset dashboard, where we can monitor each room and also modify their desired room temperature individually. Superset then automatically calculates the optimal way to reach that temperature and sends us the instructions via notifications. But this is not all. We have also created a motorized heater controller that can be mounted to any kind of knob and is able to remotely change the level on the heater. This allows the network to run on its own and change heater settings according to weather forecasts or the habits of the homeowner. According to our calculations, homeowners will also save 12% of their annual heating consumption, saving 1.6 megawatt hour, which equates to around 320 euros currently. We are Superset, turning households into super homes. In the last 12 months,
That's it. Again, no. Please come to the stage. I can see that you have some stuff with you.
Hurry up. So I don't know about you guys, but ever since the energy crisis, we always carry our own heater with us. You can never know. Do we still need a minute to set up? I didn't plan with any additional jokes, so we'll have to wait in silence. Okay. Hello, everyone. We are Team Discover here with Superset. So I don't know about you guys, but I still have a heater like this at home with the manual knob, and most households in Hungary have similar systems, which are not adapted and are not automatic when it comes to energy efficiency. So we have created Superset, which is made up of sensor cubes that are equipped with multiple sensors. So it has a temperature sensor, humidity sensor, and even motion sensors. And the idea is that we place these in the different rooms of a household, the living room, kitchen, bedroom, and these measure continuously. And this way, we can actually map a heat map of the entire home and see where the different, how the different rooms are heated, what the differences are, whether there are cold corners or not, etc. And we can adapt our heating plan according to this data. So we actually can track the data in a live dashboard. So Marcy is actually now operating it. This is not a mock-up. And we can see how the different rooms are heated. We can also change them individually, and then the heaters will adapt accordingly. But we all know that, all right. And actually, since we have motion sensors in the cubes, we can also create trends and analysis whether how the homeowners move about in their daily routines. So we can actually learn when they get home from work, what they do on the weekends or when they wake up, and adjust heating accordingly. And we can also send out notifications as to how to change the heater settings. But we wouldn't want to do that manually and go to all the rooms. So that's why we have come up with another small gadget, a motorized heater controller that we can actually mount to any kind of heater knob. Right, Christoph is my second eyes. So how this works is that we put it on the knob, and these are connected to the cubes and the dashboard. And whenever it gets a signal that it's becoming too hot or too cold, it can automatically change the settings on the heater. So this way, the system can actually can actually run on its own, and it is not needed to have our own input. We do not need to overview it. And this way, don't have too much time. Let's jump into a live demo then. So what we are going to demonstrate now is that we have the cube with the temperature sensor. We have a fire hazard here with a lighter. So Marcy will actually light the temperature sensor. You will see the temperature spiking up there. And the heater will also demonstrate that actually it should be turned down since it's becoming hotter and hotter. And you can see that the knobs are turning, and well, basically that's how it should work. And we can also do the opposite. So we have compressed air here to actually cool it down. You might have freezed it. And you can see that the heater is now trying to turn the heat up so that we shouldn't fry the heat sensor. As we mentioned in the video as well, the benefits of such a system is that we can actually use these systems together with weather forecasts to anticipate heat waves and colder environments. And this way, we do not let the rooms cooled down, and can work in advance and keep room temperature that is more efficient than what we could do. And this way, according to the studies and findings we found and our calculations, we can save around 10 to 12% on our energy heating per year, which is around 320 euros with current EU gas prices. Thank you very much. We were Superset, turning households into super homes.
Thank you, guys. Do we have questions? Yes.
Right? Yep. Oh, this is not plugged in, so it's not heating at the moment. Oh, you mean, oh, it wouldn't be on top of it. Yeah, this is just the hack or prototype that we could put together now, but obviously it would have a different sort of box here that would have its own energy source and obviously independent from the board of the heater. Yep. The roles? Sure. So we know each other since high school. We went to the same class, almost same grade. So Marcy on the far right, computer scientist and product designer, no, product owner, usually in his everyday life. So he was responsible for the dashboard. So he was the one developing it. Levi in the middle is an electrical engineer. He was responsible for putting together the hardware and actually putting together the schematics that we didn't show here, but we also have quite a detailed technical documentation that you can check out. Christoph is also an electrical engineer and professional motion designer as well, so was the one putting together the video as well. We have a fifth team member that couldn't be here today. He's in Vienna already, but he was doing the 3D printing, the 3D designing for the shells. And I'm also a computer scientist, but thankfully didn't have to code this time. And I'm more responsible for the pitching and also the business aspect of the entire thing. Thanks.
Thank you. Do we have an opportunity to try out the stuffs after the pitches? I mean, if you want to check them to get closer, then I think they will have.
We do not have a table here. We didn't make it, but we have occupied that booth by the pillar. So you are welcome to try now.
Okay, thank you. Then I'm going to give you 1 minute to put your stuff down from the stage. Okay, now we have all the teams from the hardware challenge. We are moving on to the software development part of the pitches, and we will have 4 teams as well for this challenge. And the first team would be the High Frequency Data Network, HFDN. And I would like to ask their video on the screen. And then, where is the team right now? Okay. As soon as we played your video, you can come to the stage. But until then, you can come closer to it, yes. You have a presentation.
This weekend our team got into a very new type of challenge thanks to Craft Hub and Bosch. We set a goal to develop object tracking software.
The algorithm works by sending the data through a pipeline consisting of 3 steps: the duplication, prediction making, and object tracking. At the end of the pipeline, we have a list of tracked objects with detailed properties.
The application makes it possible to visualize sensors, driver blind spots, and also the actual footage of the measured vehicle. It also provides functionality to view the history of an object consisting of previous measurements and predictions. When an object enters the blind spot area, the location prediction continues while the warning indicator turns orange and an audio signal is played to grab the driver's attention.
We used a mix of React, Node.js and 3.js during this challenge. The datasets are stored in a MongoDB database and the client loads them in chunk through an API.
For the third part of the challenge, we came up with an idea of a network connecting vehicles which can share information about the environment. This makes it possible for cars to make collision avoidance decisions together. It means they can share their measurements, so each of them has the measurements of 10 sensors. In the model we present, the red car tries to make a right turn, but the driver can't see the pedestrian on the road but thanks to the blue car's sensors, the red car is informed about the pedestrian, so it can decrease its speed or make an emergency stop before actually observing the pedestrian.
Okay, so can you hear me? Hello? Okay. So, we've been through an amazing 48 hours, and we tried our best to develop working object tracking software, and we also came up with two ideas for the third task of the challenge. But first, let me demonstrate you the solution for the first two tasks. We made a web application which visualizes the measurements and the predictions in a nice 3D view. We send the measurements through a pipeline, and at the end of the pipeline, we get individual tracked objects and their histories too. So Zoltán will demonstrate how this works.
About our simulation process, I can tell you that we get the data from our MongoDB database, and after that we deduplicate this data. That means we measure the same data from different sensors, so we call that these data can be connected to one object, for example, a car. And after that, we identified that object, a car, based on physics laws. In the next section, we try to predict the position of that object according to the next moment. And based on these data, the predictions and measurements in the third section, the merging, we merge the objects which has similar positions based on the prediction and measure data. And after we identified the objects, we display it on our 3D system. And about this system, Balint will tell you some words.
Yes, thanks very much. So for the visualization, we got that 3D dashboard. This can visualize every kind of vehicle and objects that was in the challenge. This can also visualize pedestrians and motorcycles and bicycles, but those we couldn't find in the data set, but our solution is also capable of it. We can visualize the history and the prediction of each individual object tracked by our system. And everything can be played like a video player style, but in 3D. So we get a timeline, and it can be paused and changed. Please, the next slide. And for the third part, we came up with an idea and a little demo for connected vehicles. So these sensor data can be shared by the vehicles. Every vehicle can broadcast their data to each other, and also like CCTV cameras with known locations can broadcast these informations, and they together they can build up a visualization or representation of their environment, and in this environment they can make predictions and decisions together. And for the last one, János, please.
Yeah, and during the development of our web application, we came to realize that this data is really hard to work with. So it has lots of noise, and basically we try to open it in a spreadsheet software, but it's really difficult to see what is happening. So we came up with an idea of a 3D simulator where engineers can test their prediction software or go deeper into the data and also make configurations to the models and run experiments. So yeah, that was the second idea. And we also have a live application. We encourage you to check it out. It's available on the link up there. It has a nice little tutorial. So yeah, thanks for your attention. And are there any questions?
Do we have question for the first team of the software challenge? No. Actually, I have a question, but it's not related to your project. But how hard did you find this challenge in a 1 to 10 scale?
It depends on which parts, because the data set was really noisy. That was a really challenging one. But the overall challenge, I think it was great. But other ones?
Yeah. So the data was really hard to work with, but overall we really enjoyed it. So I would say it was pretty difficult, but I'm proud of what we did.
I would rate its difficulty 8 out of 10.
Thank you. Okay. We have a question there. Yeah.
What kind of new data set? We did not yet, but we can upload it, so it can handle that. Oh, okay. That takes a few minutes, but I think we can do it. Thanks.
Thank you. So yes, one thing that we shared a WeTransfer link in the Slack channel that we put you in before the pitches. You saw that, right? Because I put all of the needed information regarding the live pitches there. There was a WeTransfer link with the new data set, and I wrote to run your project on the new data set as well. There is a team who did that, right? No? They did that. Okay, so they knew the task, but they just missed that. Okay, so let's move on to the next team, which is not other than the Vision Tracker team. We will play the YouTube video and then you can come to the stage. Where is the team itself? Here, great. Stay there and then you can come up to the stage.
I'm John and Chania from the Vision Transformer. We're doing the software challenge and we tried at least to track objects. So first of all, we modeled the data set and we used the matplotlib to visualize the data. And you can see each of this axis represents a data set. We have 4 data sets, but we chose to visualize only 3 of them. And as you can see, we're tracking each individual vehicle and we're giving it a unique ID. We used, in this place, we used the Hungarian algorithm. And also we applied common filter. Common filter works really good for position estimations and also predictive model, basically. And it's a feature on the project, at least in our project. You can turn it on and off. Right now it's currently off. And when you're testing it, you can try or at least turn it on. It works really good. We can also detect blind spots to some degree, like when it's not that much distance from it, you're gonna see a red light and it shows. There's just not so much collision right now for us to be able to make that claim. This yellow box here represents one part of the data set. I think it's from the 3.2 data set. This also yellow block represents that. This 2 is a combination of 2 of them. And yeah, pretty much.
The stage is yours. You have 4 minutes.
Hello. As you can see, I worked on the software. All right. The name of the stuff, I called it Vision Tracker. We were given data set by the Bosch team to perform the software engineering challenge. The data set was messy, like the first team said. It was obvious. And we were meant to visualize the movement of vehicles. We are also meant to track the vehicles. We are also meant to detect blind spots and do a lot of other stuff. So the first step towards any tracking system or detection system is for you to understand how objects move in sequences. Most detection software just stops at recognizing each frame individually without any connection to any other frame. So the first step to my solution was to track the frames. So given the first frame and the second frame, I want to know which object is the same. So I want to give identification to the vehicles because it wasn't given in the data set. And okay, first this is challenge definition. And also this is the solution for the test sets provided to us. You can see it's visualizing and also doing the tracking, giving ID to new vehicles in the scene. I'll come back to this later in the end of the presentation. So the first step, I used the algorithm called, surprisingly, the Hungarian algorithm. It is a bipartite graph algorithm that's able to do a one-to-one mapping from a frame to another frame. The technical details of the algorithm is not so important. You can go on Wikipedia and you can find solution to it. After frame-to-frame recognition and also tracking of the object, the next step towards the system is also to estimate motion, because estimating of motion is very necessary. And we also want to be able to predict what the next step is. As we do in live, we also try to model our beliefs. And in order for us to model a belief of a robotic system, I use the Kalman filter. We can also use other sophisticated model, but due to the fact that 3 days challenge applying such complex models like the recent development in graphical neural network would be difficult, so I settled on this. I was able to some degree of accuracy, but it was still kind of faulty, since I also had to find a way to synchronize the time differences between each data set. So applying the Hungarian algorithm, then the Kalman filter algorithm, we got some degree of accuracy. The data set was given, like, they didn't give us the motion of the vehicles, we didn't get a lot of information, so we have to implicitly measure this using physics. So using game physics, I was able to calculate the angles to which the vehicles are turning, also calculate the speed of the vehicles and also the relative motion of all the vehicles around it. And this way I was able to simulate it at least to some level. I think I pressed something. Sorry for that. This is the libraries I used for the application. I used Matplotlib, sorry, to visualize the data set, and also used NumPy extensively. And pretty much this is the visualization of the training data. I don't know why it's not moving, but if you check each of the videos or each of the blue boxes represent the car, the one on the center represent the reference vehicles, and the other vehicles are position relative to the vehicles. The vehicle doesn't move from that position, but it's simulated. Like if I could play the video, you could see that motion is being simulated through the axis. You can see the axis moving, and you can check or in some way infer the velocity of the vehicle. Pretty much that's it, and I appreciate you guys for listening. Thank you. All right. Yeah. In the data set, it was provided for different files. So for two of the files, a GPS tracker was given, and this in the yellow vehicles are the two different data sets. So that is how I was able to visualize it. So this is basically visualization in combination from that data set and to the other data set. So I had to synchronize the time difference. I had to do some sort of sampling method, and that is how we got to this point. The yellow GPS, the middle, the car, and the blue ones are the other reference vehicle. And from the reference ID, you could easily just, maybe from the camera stuff, you could improve this model extensively in the future. Yeah.
Okay, other questions? No. Thank you very much. Let's move on to the third team of this challenge, which not other than the Drive Like a Bosch team. They are there. Okay. We will play your video and then you can come to the stage. Okay. You didn't have any sound. Is it okay? Oh, okay. Then next time you can maybe just sing a song during that or something. Okay, please come. I can see that we have members from several countries. Can you introduce yourself? Where did you come from?
I'm Iftikhar Mahmoud Ratul. I'm from Bangladesh. I'm Christina Piri. I'm coming from Cyprus.
I am Tmileim Saloju. I'm coming from Nigeria.
And I'm Mátyás Nyilas, and I'm local. I'm Hungarian. So can we like stop the... Okay, cool. So, first I'd like to apologize for the video. Like, it didn't have much stuff in it. It's because we spent our time building the technology, not the video. So yeah, we focused on implementing the stuff needed for the challenge. So yeah, we achieved accurate filtering of the sensor data, and also pretty accurate predictions and coverings of the blind spots and places that the sensors just couldn't reach. Yeah. Actually, I'm just gonna show it working because it's interesting. Can I use the HDMI? So yeah, I showed the one of the working or training data sets running first. Then I'm gonna move on to the actual validation data sets. It's gonna be interesting. So as I run the code, it opens up. And yeah, we can see a visualization which belongs to a virtual environment. The red dots symbolize noise. So any kind of false readings or temporary vehicles like passing cars or stuff we don't really care about in this situation. So okay, so yeah, there are multiple views. The first is the raw sensor data. This is fully unprocessed. This is what the program gets. And in the actual simulation, we managed to take that sensor data and like process it in a way that it recognizes already existing objects and merges them with the new readings. Also, we keep track of lifetime of objects. That's the main like the main way of identifying them. And also, you can see warnings on the screen notifying us about like passing cars and everything. So this is the third view, which is the final rendering. It shows the actual environment. Yeah, I'm gonna show another data set because the challenge. What? Okay, so no. Cool. So actually, it can track cars even if they are like behind or this trackpad. So sorry. So if we get, sorry, I'm gonna like pushing it a bit. So if we overtake someone, just please, car, there's a car. Yeah, here it goes. So if we overtake someone, hopefully it will work. Yeah, it remains a car. As it knows, it was a car before, and it tracks with the other sensors, improving its lifetime. Yeah, that's it. It works really, really good. And I'm proud of my team. Thank you.
Thank you. Is it your first time at a hackathon? Yes. Okay. Next time you will be much more greater in the stage, so don't worry. Okay. Do we have any questions? There is one.
So I could see that some objects were colliding with each other. So I wanted to ask you, like, how you deleted the duplicated objects. Like, I mean, the objects that were detected by multiple sensors at the same time.
So it can be solved really easily by fine-tuning the application. I've got variables in the Python script. Actually, it's a really organized and commented Python script. So I've got variables there, and I've actually spent like an hour fine-tuning it, but it can be really improved. And this is just a concept program. To basically implement the idea of this, and it can be improved later.
Okay, thanks. If you have any other additional questions to the team, you can ask them after the pitches. But now we will have our, thank you guys, our last pitch in the software challenge, and this team competing online. So we will broadcast them through Google Meet, but before we do that, we will play their YouTube video as well, and then you can see them on the screen only, but they will do also a 4 minutes long pitch. And yes, after their pitch, the voting will open on the Junction app, so please pay attention to this, as you will be able to vote for like 10 minutes. And during that time, I will ask one of the representative of Bosch to come to the stage and hand over the challenge prizes. But now, can we see the YouTube video of the last team, which is not other than the predictive object tracking team? Yeah.
Welcome to this short presentation of our solution for the Bosch 2022 Software Challenge. As our assignment, we have created an object tracking system that is able to estimate objects surrounding our vehicle based on sensor inputs, and that is also able to predict the location of these objects over time, even out of the sensor's field of view. We have also provided a graphical user interface to visually represent these objects around the vehicle. Our system first processes the bulk input data that we receive from all the sensors, structures it, and then passes it on to the object tracking module. The tracking module creates an internal representation of the objects in our vehicle's environment based on the sensory inputs and the previous state of our model through a filtering and pairing algorithm. The system then also predicts the future object states for the next timestamp, so they can be also tracked in the blind spots. The blind spots here are represented as rectangles next to our vehicle in the user interface. All the estimated object data is passed on to the UI, and they are then represented here as time progresses with color-coded dots. For example, the green dot here corresponds to a truck. If we estimate that another vehicle is in our blind spot, then the corresponding alarm will go off at the right bottom of the screen. On the right side of the screen, we also provide the recorded video of the current test drive from the front camera that is synchronized with our object tracking model. There are some control buttons available, and for validation purposes, we also list out here sensor values from the ADMA sensor.
And now I think that we can broadcast the team from online. Bless you. Hey guys, are you here? Can you hear me?
Yeah, I can hear you.
Oh, great. Hey, nice to meet you.
Oh, wait, there's a feedback.
Okay. The stage is yours, Daniel or Balint?
Daniel.
Daniel. Okay, the stage is yours, Daniel. You can make your presentation. You will have 4 minutes to do it. And then if there's any question from the audience, we will ask it for you, okay? You ready?
I'm ready. Can you see my screen?
Yes, sure.
Okay, thank you. So, I'm Daniel and my teammates are Adam and Benedict. We have focused on the first 2 parts of the object tracking challenge. Our architecture, our solution can be segmented into 3 main parts. The first, the data processing module that segments all the incoming bulk data that we received from the Bosch team. It was kind of difficult to work with this data, so had to apply several parsing and pre-filtering. After this, we structure the data, then pass on this data to the object tracking model that creates an internal representation of the objects in our environment. And also, at every time step, it updates the location and parameters of our objects based on the incoming sensors, sensor data, and the previous prediction of our internal model. We feed all our results to the GUI. We created the user interface to display all our calculations and the vehicle and its surrounding. Basically, the main challenge is to filter out the huge amount of sensed objects or data coming from the sensors and remove duplicates and match our internal representation to the sensed objects, which we can do through a special matching algorithm and filters. We didn't apply the Kalman filter, but a simpler low-pass filter that we wrote by ourselves. After updating our object pool, the internal representation, we can also predict the next locations of our objects, basically the parameters for the next timestamp. This is important so that we can predict the movements of the other vehicles in our blind spot. After this, we pass all the data to the graphical interface, and we can display in real time what's happening around the vehicle. On the right side, we also provided the recorded video of the front camera, so if we can validate what's happening in our model and in the real world. And the obstacles that we detect on the playing field are color-coded. So the beige dots, which are kind of unfortunately hard to see, those are the cars, and green ones are the trucks. And we also run this model with the received data sets we just get from the Bosch team. I can show you how it works. 1 second. So I can start a simulation by the start button, but we didn't get the recorded video as part of our dataset, so I cannot show you what's happening in the real world. I can just show you what's happening in our model. We can see cars approaching in the other lane and the opposite lane, and some trucks. And basically, if a car enters the blind spot, our alarm will go off, indicating that there is something in our blind spot. basically that's the gist of our model. And we have an idea for future applications of this system. It could be used for self-driving convoys of self-driving trucks that share their information with each other so they can travel closer to each other to reduce traffic congestion and so on, avoid accidents. But we haven't implemented anything of this sort. So that concludes my presentation, and if you have any questions, I'm happy to answer.
Thank you, Daniel. I don't know if we have any questions. Again, yes, we have one. You have several questions. You have questions to all teams.
So, okay, thank you. Did you make the pedestrian and the cars have the same color?
No. I can go back to show you.
Yeah, please.
No, the pedestrian is yellow and the car is beige, but on your screen in the event hall, I'm not sure if you can see the difference, but the pedestrian is bright yellow, the car is beige.
Oh, okay. Could you show me the warning of a car entering the blind spot?
Yes. I don't know how long we have to wait, but we'll see. See? It entered the right blind spot and the alarm went off.
I see that the green car is right next to the yellow car. How is this possible if the two lanes are right next to each other?
Where?
Like,
Here?
Yeah,
I'm not sure. How do you know it's only 2 lanes?
because there was another car walking, like running like on the other lane.
I'm not sure.
Because there was a yellow car on the top of the window, and that car was running like in the opposite direction, and there was a long space between it and the car in the middle, which is the host car. So supposedly there's another lane in the other part.
I don't know. I haven't seen the video of this data set. They haven't provided us anything. So I cannot answer the question.
Could you also tell me like what is the purpose of ADMA? Because
ADMA is used for validation if it was available, but it's too far away to show you on the screen. If it will be closer to the vehicle, then we could use as a validation of a model.
Okay.
Sometimes.
Could you explain like what estimation means?
It was the estimation of the ADMA tracked vehicle, I suppose. Yes.
Yeah, estimation of what?
Of the ADMA vehicle.
Okay.
Position of ADMA vehicle.
Okay.
That is tracked by ADMA.
I think you can find each other on Slack and discuss it further because we don't have that much time. But I'm happy that you are this interested in others' projects, so please do and talk to each other. But now we reach the point where I have to finish the pitches and ask you to vote on Junction App because we opened the finalist voting, and I've also sent the jury members and the mentors a link where they can make their vote. Did you get that email with the links? Yes, thank you. So you will have around, I think, 10 minutes. And in the meantime, I would like to ask Attila Mészáros, Director of Software Engineering at Driver Experience at Bosch. He will do a little speech, and then he will hand over the challenge prizes to the challenge winners.
Thank you, Wanda, and hi, guys. Happy to be here and happy to be with you. Hope you are tired. Who is tired by typing your vote? Happy to see you. because such a challenge means you need to be tired. Such a challenge needs a lot of things, so I would say not just brain power, not just creativity and stamina that you are wake up and you are still have a moving and working brain after 48 hours, but that means as well that you can communicate in a team, that you can work together in a team, that you have some leadership and some attitude, some kind of cooperation style where you can get the most out of this 48 hours. As part of the jury, I had the pleasure to see some of your results, at least the software side of the challenge, and I've seen a lot of different solutions for, I would say, the same challenges. And it was very inspiring to see it. I'm as well an engineer, and as an engineer, always have a working brain to create and to create something new which was not existing before. And these challenges were about that. At Bosch, in an average project, I would say we have always 3 topics: to be on quality, to be on time, and to be on cost. I would say in these challenges, the on cost part was maybe not mostly in focus, for sure, implicitly for sure, but on time you got a massive pressure, and on quality that's what you had to present here. And I was impressed that you could make things within the on time part, so within the 48 hours with a lot of results at many of the cases, and you could really present a very good quality in as an answer for these challenges. To be at Bosch, we have one more thing on top of this triangle, and that thing is what you can see on the billboard as well: invented for life, Technics fürs Leben, vagy magyarul, or in Hungarian you can call it életre tervezve. That means that each and every product we are doing at Bosch, and I hope you could recall this mission in the challenges as well, needs to be connected to a greater God, so to a noble mission, I would say. So saving energy for a smart home, this is not just about money, this is as well about our environment. Blind spot detection is not just a feature you want to sell and earn some money, but that save lives. And at Bosch, it is very important that each of our products, be it in the automotive or be it in the household industry or whatever we're doing, is connected to a mission which creates some positive result for humans. While seeing your challenges, we had a hard time to be the jury and to really be able to judge, hey, which one is better than the others. I would say at Bosch we have some history of making structured and objective decisions, and that's what we used here as well, to not be based on feelings, but to really see what you have achieved, how that works. For instance, and as I mentioned, I was working in the software jury, how sophisticated and how effective your tracking mechanisms was. And if you had an object which was tracked by 2 different sensors, and what to do while merging these sensors positions, or you just detect that they are double detected and you just delete one, or you have a good idea how to merge them and track these merged objects further. So we had different solutions for this topic, and I was really impressed of some of these. So I would not like to waste your time and to make a big speech. So thank you very much once again for your time. Thank you very much for your energy, and happy to see you could even smile after 48 hours of such a hard work. So great job done, and yeah, we will see the final results. Thank you.
Okay, and right before I hand over the prizes and you can call the teams up to the stage, I would like to also remind you to do, we have an audience award voting as well. We've put out a form into the Facebook event. Please share it with your friends, on your page, with your family, with your neighbors. I don't know, collect votes, because we have a 500 euro prize as well, and you can collect votes from your teams, from your friends and anyone. And in this voting process, not only the finalist team can participate, but also the other teams who haven't won anything. I mean, not a challenge prize nor a grand prize or something. So use this opportunity to win 500 euros. And now I think we have the time to announce the challenge winners. And when I say to my team that we can close the voting right after the handovers of the prizes, then I'm gonna tell you that. So let's see first of all the software winner, which is the...
So the winner of the software challenge is the HFDN team. Big applause to them. They still can smile. Great job. As well, the same amount of applause to the winner of the hardware challenge, which is super sad. Great job. Thank you, guys.
Great. Thank you, Attila, and thank you, the mentors and the jury as well, for being here. And now I hope that all of you could make your votes. You did that, right? Yes. You voted for the audience award as well, right? Please tell me something. Okay, thank you. Thank you. So now I would like to ask my team, to stop the voting. And until they count the votes, I'm gonna present you some exciting things. So thanks, Attila, for being here with us. And yes, I really just collected some things and want to say something to you. So you know that we have more than 500 registrations to the event, which is a really big number, but you can see that only 75 teams were made during the hackathon for 2 challenges. 42 projects have been submitted, but only around 25 made to the finals. I mean, to actually get a valid project who provided a repo, who provided a video. So only 25 teams were here to have the opportunity to get into the finalists, and 8 teams got the chance to present their ideas in live. And yes, I should show it to you before, but actually I just wanted to say to you that it was really a good time being here with you. I hope you enjoyed being here with us, enjoyed the challenges. If you have any questions or you want to get feedback on your projects, please tell us, and you can, I think, also catch some of the jury members here as well still. So do not be afraid and ask for feedback from them. And also you can contact each other, because you will see a project gallery in the Junction App event for the Code Like a Bosch event. And there you can see all of the projects, also the draft ones as well. And you can see who are the team members. You can contact them on Slack, use the channel if you want. And please come other hackathons as well, because they are really great opportunity for you to improve, to get to know companies, and also to network a little bit. And yes, congrats to the guys who won already some prizes. And I'm gonna check if we have the final winners, but not yet. Not yet. So, okay, how did you feel here? How you managed to do your project during 48 hours? Was it easy? Coffee. Only coffee or Red Bull and coffee? How many Red Bulls have you drank? Too many. Okay. And did you go home for sleep or you stayed here? Okay. Oh, nice. And the beanbags wasn't comfortable enough to stay here? Oh, you live nearly. Okay. That's the good luck. Okay. Oh, nice. So we have the grand winner already. And yes, we have that. And we will also have the audience award winner, I think, in a few seconds, maybe. I'm looking for some of my team members to tell me that yes, we have. Yes, we have. So you know that the grand prize is 5,000 euros. All of you have a plan how you will use it. What are you going to do with it? Did you think about it yet? You go to the Maldives or... What? Pay for the gas. Okay. Nice answer. So, I would like to announce the audience award winner for first. Yes, we have all of that. So now we will hand over the prizes. Vicky's, bring it to me. You can stay here. Oh, you cannot stay here. So the winner of the audience award prize, which is 500 euro, is the Helicar team. Do we have them here? Oh. Okay, I think that they are competing online, so I'm gonna keep it now. We will take it to the office. If they want to get it, then they can visit us, and we will hand it over to them. But now, then move on to the grand winner of the event. Are you excited? Because I am. So, but let me check the full name of the team, which is the High Frequency Data Network. So please come, because you were the lucky team who won, I think, 8,000 euros. Oh my gosh.
Do we need to give a speech?
Then please do it.
Well, actually, this was our first hackathon. Yeah, we came together for fun. But yeah, I think, yeah, I'm really happy and really tired also. Okay, thank you.
I'm proud to my team. So thanks everyone.
Thank you too. Please stay here because we are going to make a photo. Attila, can you come to the stage? Just to do a quick photo with them. Okay, great. And right before you would go, I would like all of you to come to the stage and create a memory together, because I think that we are here like it's 50 people or more, and it would be really great to have a group photo with you as a memory, and you can also share it. And please stay here and come. All of the staff members, I would like to ask to come to the stage. What do you say? Zenki, even Zenki, come.